Don't get me wrong, there is a time and a place that it sometimes is a necessity that there might be a quiz on a Monday. For example, let's say we had a snow day on a Friday when the quiz is going to be on a Friday. You know that quiz will be on that Monday. Things like that. If there's a time crunch where we're running out of time getting close to finals or close to the end of the year, we have to fit in one extra section or one extra thing. It does happen. I think over the past 2 or 3 years, it might have happened twice, maybe 3 times in all of my classes. So you figure in 3 years' time, that's 15 different sections, maybe 3 tests or quizzes like that. So it's very rare. So what we would do is we would quiz on Tuesday. Now, we'll get through all of the material for tomorrow without a problem. We'll probably even have half the period to get the work done, which is good because that leaves you nothing for the weekend. But then on Monday, I'm going to expect that we have everything done. Otherwise, I will give you that quiz. Is that fair? Okay. What's your name? I'm adding to it. We're going to add to it because we're saying the same section. Might as well just add to it. That way, if you had to finish up one or fix that one, you can fix it. It's no rush. So here's what I want to look at. And we kind of discussed this a second ago. If I'm on a segment, and I'm on segment A, M is my midpoint, and B, and I start at 0, and I walk bless you. And I walk after I lose my shoe. And I walked 12 feet. I started at 0 and I walked 12 feet. What am I going to end up at? 24. Okay. I wind up at 24 feet. Yes, sir. I'm just saying in general. Okay, if you know one distance is halfway, you've gone 12 feet, and you're halfway there, how many more feet do you have to go? If your car trip is 60 miles, you've gone 30 miles, how much further do you have to go? Same basic principle here. Now, what if I change it, and I start on a number line, and I start at, I don't know, -5, my halfway spot is at 3, where do I end up then? If I start at a negative number, I walk on a number line. If I'm going from -5 to +3, do I go up the number line or down the number line? How many?
8.
Okay, so I have to go to what number then to end up?
Is it +5?
No, it's 11.
It'd be, because this is going up 8, so what's 8 more here? 11. So basically, 3 is the midpoint of 11 and -5. Do you agree with that?
Mm-hmm.
Yes, sir.
So in a scenario like that, you just subtract 3 minus -5. Just to see how much it is.
You're even overthinking it.
Oh.
Because, go the other way. If I start at 4, my halfway point is -3. So I'm starting at 4. Going from 4 to -3, do I go up or down the number line? How many do I go down?
No.
Let's try this again. 4 to -3 is how far? I went down 7. What's 7 less than -3?
-10. That's how you can't go.
Depends on which way you're walking. Are you walking up the ladder or are you walking down the ladder?
So you can never go negative.
I'm just saying, I'm just counting, all I'm doing is counting the number line. Okay, I'm counting on a number line. I'm not counting distance. I'm just figuring out place value between the two. Because in essence, what this is allowing us to be able to do is to take a segment that is AB, and knowing the midpoint, if I know my ordered pair is at 3 and -2, and my midpoint is located at 6 and 4, I can find the missing endpoint here that makes this a midpoint. So if you think about it, when you're talking about ordered pairs, you have an X value and a Y value. Your midpoint is just the average of the two.
But wouldn't you just do x1 plus x2?
Sure, if you want to do that algebra problem, by all means. Or, watch this. 3 to 6, do you go up or down? How many? What's 3 more than 6?
9.
Ooh. Negative 2 to 4, do you go up or down?
Up.
How many?
6.
What's 6 more than 4? Done.
It's way easier than doing, because I don't remember the equation.
You can do the equation. Your midpoint, you're right. You're absolutely correct. There is nothing wrong with that. You can say that 6 is 3 plus what divided by 2. Go ahead and solve that. It works. Multiply both sides by 2, you get 12. Subtract 3, you get 9. Hey, what did we get? Which way is easier, counting or math? See what I'm saying? When you're working with these things called a missing endpoint, you're going to be given a starting point and a midpoint. What's the last point? All you have to do is know how to count. And apparently counting is, I've heard a few problems here or there, so you gotta be careful with it, but that's all it is. That's using the midpoint formula. Don't ever use it. It's a pain. Why? Why bother? There's no reason to do that much math at all. There's no reason. You lose him? Oh, I thought we lost you. I thought he was making fun because it looked like we lost you for a second. Yeah. Same deal. So A is my midpoint, or A is my endpoint, M is my midpoint, B is my endpoint. If I start at negative 4 and 3, my midpoint is at negative 7 and 0. Again, all you're asking yourself is the following. From negative 4 to negative 7, do you go up or down the number line? How many? You went down 3, very good. What's 3 further down the line from negative 7?
Negative 10.
From 3 to 0, you go up or down?
Down.
How many?
3.
What do you end up?
Negative 3.
Ladies and gentlemen, there is no reason to math this. You can count. Okay? That's the idea. The book, every single geometry book that I've ever seen, tries to force you to do all those algebra problems. Why? There's no point to it. Yes, sir.
Would it be like a point where like X is going up and Y is going down?
Absolutely. We can do that. Absolutely. That makes no difference. So let's see. Negative 2, 8, 6, 4. This is a great question. He asks, is it possible that X could be increasing and and X is increasing, Y is decreasing? Absolutely. Nothing wrong with that. Negative 2 to 6, up or down? How many? 8. What's 8 more than 6? 8 to 4. Up or down? So what's 4 less than 4? 0. Aren't these the easiest things known to man? Don't overthink it. Take your time counting, because that's hard. I roll my eyes. Last one. Actually, I'm not going to draw it. M is the midpoint of AB. Midpoint's at 3, negative 6. A is at 4 and 12. Where's B? What do you think I would suggest that you do? Right. Draw it out. What's that?
This is why you're growing exponentially.
Don't read into it thinking about it's growing that fast. I'm just picking numbers. Because all of this stuff that we're doing here is all linear, so don't worry about any of that. This just means it has a very steep slope. If you plotted all the points, that's just going to be really kind of crazy like that. That's all. Yeah. But I see where you're going. That it's increasing at an increasing rate. So no worries. in the essence of time here, all you guys gotta do, I'm telling you, just draw these pictures. Draw these pictures, write them out, and count. From 4 to 3, do you go up or down?
No.
How many? What's one less than 3? From 12 to negative 6, do you go up or down? How many?
18.
What's 18 less than negative 6?
Negative 24.
Yeah.
No, 20, yeah.
I had to think about that too. Okay? What I want you guys to do this evening then, it's the exact same page that you're on. I think you just flip the page over. So it'll be page, what is that, 20? Yeah. There are 6 of these that I would like you to do. So this is on page 20. And just add it to the work you guys have going right now. It's 25 through 30. So this is page 20, same section. What is that? 1.3. We'll do numbers 25 through 30. I have it right here on the board right now. If you just want to take a quick picture of it, what they did with their segment, they said M is the midpoint of section of segment RS. So you just got to write it differently. Instead of A and B and M, it's RS and then the M. Okay, not too shabby. Just remember, guys, when you see stuff like that, when it says find missing endpoint, just count. Don't map. Count. So, nobody's easy math. You don't think about it. All right.
Mr. Murphy, why didn't you wear that yesterday?
I didn't know about it yesterday, so I figured I'd wear it today. Nobody tells me things. I'm not in the loop.
I think it's weird.